Welcome to today's notes on properties of matter and types of mixtures. Before we start talking about the properties of matter and types of mixtures, let's just do a quick reflection on this unit so far and what we've learned. So this unit is based upon the characteristics of matter. It's really what we're looking at. And we're looking at the characteristics of matter through the lens of special effects in movies and using the characteristics of matter to create some really cool special effects. In section 1, we studied pure substances. So section 1 was really all about pure substances and how pure substances can either be elements made up of just elements or compounds, and that compounds are made up of more than one element. In section 2, we looked at the states of matter. And what's happening to energy when we have phase changes as well. So states of matter and phase changes. So in this section, sections 3 and 4, we're going to be looking at the properties of matter and specifically how those are seen in mixtures. So this section is focusing on mixtures, but it's also focusing on properties of matter which are present in both mixtures and in pure substances. So the physical properties of matter, there's three general terms that are used to describe the physical properties of matter, and how this fits into special effects is you're going to want to consider these properties in considering some of your special effects. So for example, if you want to make a special effect of like a cartoon, think about a cartoon where you have a character fall from a large height and they kind of splat. If you wanted to, and then in the cartoon they also come back up to life. If you wanted to do a special effect like that, you would have to consider the physical properties of the materials that you're using to do that. So these are some of the things that you want to consider. So physical properties are used to describe substances, and it also is used to distinguish between different substances. So one of the first properties that you want to think about is the texture of a substance, and that's the characteristics of the surface of a material or object. And a lot of you guys have heard the word texture before. We talk about it with fabrics, we talk about it with art, and so this is something that you're going to want to consider. So we have two objects here. It's the same substance, it's just different textures of that substance. So the item on the left we have here is a rough texture, and on the right it's a smooth texture, but it's the exact same material, just different samples. Uniformity is how consistent the material is throughout it. So on the left here, we have a very uniform distribution of the components that make up this material. And over on the right, we have an uneven distribution of those components. So evenly distributed means uniform. It's uniform, that they're evenly distributed. It's gonna be the same composition throughout it. And here you have a fragmented distribution where some parts are more heavily weighted in one area than in another. And another one is the strength of a material, how durable it is, or how well a material can withstand the application of force. So diamonds, for example, have a very strong, they're very strong material, and they can withstand a great deal of force. So when we're talking about mixtures, so this is talking about mixtures. Um, a homogeneous mixture is a mixture that's uniform throughout. So the different components of that mixture, the different parts of it, are distributed evenly throughout the whole thing. So you can see there's blue dots throughout this whole thing, and there's red dots intermingling with those blue dots evenly throughout the whole sample of this substance. Whereas a heterogeneous mixture is a substance that's not uniform throughout. There's usually clusters of areas. So here we have a mixture. In this mixture, we have the blue dots are on the outside of the sample and the red dots are on the inside of the sample. So they're not evenly distributed. They're not mixed evenly throughout the whole thing, making that a heterogeneous mixture. Solutions, so again, this is still mixtures. Solution is a homogeneous mixture of two or more substances. So when things are evenly distributed, it's called a solution. And those different parts of the mixture can be the same. It can be the same phase. It can be a liquid and liquid, or they can be a different phase. You can be a liquid and solid. They can be a liquid and a gas. In the case of soda, you have a liquid and a gas in a mixture. So the phase or the state of matter isn't really that important. Most of the time, though, that we think about, so when we think about solutions, the ones that you've probably used before or you've encountered in your daily life, are made up of a solid and a liquid. And when you mix them together, it looks like a liquid. So the solutions are made up of two parts: a solvent, and that's the substance that is doing the dissolving. In this case here, water is your solvent. And the solute is the substance that's being dissolved. So solutions are usually described based upon the solute. So this is usually the descriptor. So in this case, our salt is our solute, our water is our solvent, so we call it the solution salt water, and salt being the descriptor. The next type of mixture that you can have is a suspension. And a suspension is a mixture when the substances that will settle out, two or more substances that will settle out when left alone. So if they're settling out, you're going to have a situation where they're not evenly distributed, which means suspensions are heterogeneous. So they, again, same thing with solutions. They can be the same phase, they can be different phases. That's here nor there. Doesn't really, it's not that important in determining whether it's a suspension or not. So an example of a liquid of two liquids forming a suspension is oil and water. So here we have pictures of oil and water. When you mix oil and water, you initially get this right where they're kind of intermixed, but you can definitely separate out the oil here, even though it's in bubbles, from the water. You can visually separate it. It's very easy to do that. And when you let it settle, you get a layer of oil on the top and you get a layer of water on the bottom. So that's a suspension. Another example of suspension is dirt and water. So if you mix dirt and water, initially you can see the dirt, it looks pretty uniformly distributed, but as time passes and you let it settle out, the dirt clusters more and more at the bottom, and eventually you end up with just a layer of dirt and a layer of water. And so because they settled out, that makes it a suspension. And this area here is dominated by the dirt, and this area here is dominated by the water, definitely making it a heterogeneous solution or heterogeneous mixture. The last type of mixture that we're going to be talking about is a colloid. And colloids are different because they're in between solutions and suspensions. So colloids it's a mixture again that can stay suspended indefinitely, so it doesn't settle out. So it's not a colloid, but it's not truly a solution either, even though it might look like a solution. So what what separate what changes differentiates a colloid from a suspension is something called the Tyndall effect. And the Tyndall effect is probably something that you've actually seen in movies. Um, so this is a picture of the Tyndall effect. So in this container on the right, you can see that we're shine. So light beams are being shown through both of these containers, and the one on the right, you can actually see the light beam. The one on the left, you can't see the light beam. So that means that the one on the right is displaying the Tyndall effect, and what's happening is the light that's being shown through that is actually being scattered when it hits the particles of the colloid. Um, and so, but in the one on the left, the particles in there's no the particles aren't scattering that light, so you can't see it, which means that this one here is actually a solution, and the one on the right is a colloid. So examples of colloids are smoke. You have particles of a solid distributed in air and in a gas, and that anything that where you have particles of a solid distributed in a gas is actually called smoke. So that makes it a colloid. And if you were to shine a laser beam through smoke, you would definitely see the entire path of the laser beam, making it a colloid. Another example of a colloid that you're very familiar with is milk. If you were to take some of the milk and you were to dilute it down, add a lot of water to it, and give it a good stir, mix it evenly, you would see that you would also see the path of the laser beam. And the last example is Jello. So Jello is also a colloid where the parts are suspended indefinitely. And again, even though Jello might look like a solution because it's clear, you can see through it all the way. It actually does scatter that light, and you'd see that light beam throughout it. And when I think of the Tyndall effect, what I think of in movies is those security systems that have laser beams where a character will spray hairspray or something out or some other mixture into create a colloid to display that laser beam so that they can step over it and not set off a security system. More physical properties of matter to consider are elasticity, or how well a material resists deformation and returns to its normal size or shape after a force has been applied. And examples of that are a rubber band versus taffy. A rubber band stretches really far and can be, but it returns back to its shape as soon as that force isn't applied anymore. Whereas taffy will actually, if you apply a force, it'll stretch just like a rubber band will, but it lacks the elasticity, and so it won't return back to that normal shape, and it's just going to stay stretched out. Another physical property to consider of materials that you're using is bounce. So bounce is a material's ability to return to its original position when dropped from a given height. And yeah, you think of a ball when you think of bouncing. So examples of that are a soccer ball versus a bowling ball. A soccer ball has much more bounce than a bowling ball. A soccer ball is gonna when it has when it's thrown against the ground, it'll come back up pretty high when compared to a bowling ball. If you think about a bowling ball, It might bounce a little bit, but it pretty much just goes thud on the ground. So it doesn't have a whole lot of bounce. And the last physical property of matter to consider is malleability, which is how easily a material can be hammered into different shapes without breaking apart. So here we have a sample of gold. This is gold ore, and so gold is actually hammered into coins because it's very malleable. And it's actually the most malleable metal um, that exists, which is part of why it's used in jewelry and used in coin making, because it can take that, you can put it into different shapes very easily without it breaking apart. So the last thing to consider is what happens when we put different materials together. When you put different materials together, you form a composite. So a composite is a material made by combining two or more substances with very different properties to make it more useful. So composite materials, while made of different substances, have different properties of both the original substances, of all the original substances that were used to make it. And these are found in all sorts of different technologies. So the different applications of composites are huge. You find them in cars. You find composite materials in cars. You find composite materials in helmets. You find composite materials in golf clubs, in baseball bats, in airplanes, in ships. Um, they're all over the place, and so the reason that most the companies and composites are used is because they're usually stronger, lighter weight, and more durable than other materials. The downside of composites is that they actually are very expensive to develop because there's a lot of research that has to go into making the composites. But once they've done the research and development of it, they're very useful and very heavily used. So hopefully these are the properties of matter and the different types of matter that we've talked about have been able to spark some ideas for you for some of your special effects and inspire you to make some awesome projects.